Hello everyone, in this session we'll discuss another question on normal distribution. Hello everyone, let's see another question on normal random variable or normal distribution. It says for x is a normal random variable with mu equal to 3 and sigma square equal to 9. Find, first option is probability for this range of 2 and x. The first thing is the mean is 3 and the standard variance is 9. Definitely this is not a standard normal variate or standard normal distribution with n 0 and 1, right? So we need to make a transformation that has z equal to x minus mu by sigma. So we'll consider mu equal to 3 and sigma is equal to also 3. In that case we can transform this to probability 2 minus 3 by 3, and instead of z, now after transformation this will become instead of x it will become z 5 minus 3 by 3. So this is for the range minus 1 by 3 and up to 2 by 3. Fine. Now we know that this is going to be nothing but phi of 1, this is 2 by 3, 2 by 3 minus phi of minus 1 by 3. And we have studied that phi of minus x is given by 1 minus phi of x. We have seen this in the previous question also. So this will become phi of 2 by 3 is like 0.666 minus 1 minus phi of 1 by 3 is 0.3333 and like that. So we can refer the values for both 0.66, this is 0.66, and 0.33, so this is 0.33, 0.6293 and so on, right? So we can use these values and find this expression to be finally 0.3749. Putting these values will get 0.3749. Now the second part says find probability for x greater than 0. Now had it been standard normal distribution, x greater than 0 would have been directly 0.5, but it is not standard normal distribution. We'll have to convert it into the standard normal and we'll see that what is this value going to be. So this will be probability of z greater than 0 minus 3 by 3, or this is going to be probability, I'll say minus 1 for z greater than minus 1, right? So z greater than equal to minus 1. So first of all, what is z less than or z up to minus 1? It is we have seen this So this part is z greater than certain value. Let's say this is, now that we have converted into standard normal, let's say this is -1, this is 1. So we want a value greater than 1, right? We want a value greater than -1. So greater than -1 is on the right half of this -1. So this will count all these values, right? But do you observe that any value greater than -1 is also same as any value less than 1, right? This will be any value less than 1. So this directly becomes, z less than equal to 1, or directly you can say this will be phi 1, which is 0.8413, right? Like we have seen that probability for x less than minus a is same as probability of x greater than a. Similarly, probability that x is greater than minus a is same as probability that x is less than a. Getting my point? If it is equal to, you can put equal to. So x less than, so this, the case we are talking about is this one. X is greater than -1 will be same as x is less than 1. -1, 1. -1, 1. So I can directly write this, because we have seen the shaded region. This red region, that is the value greater than -1, is same as the value less than 1, right? Next is probability that mod of this value is greater than 6. So we'll have two cases here. This is going to be probability that if you take the positive part, like x minus 3 is greater than 6, then this will become x greater than 6, 6 plus 3. I can directly write 6 plus 3 equal to 9. Also, for this being minus 6, greater than minus 6, this will become minus 6 and plus 3, which is minus 3. So this will be less than minus 3, right? There are two possibilities. It can either be x greater than 9, or it can be less than minus 3, right? So let's transform this. Let's do it here. Let's transform it into the standard normal, and we'll see for greater part this will be z x minus mu by sigma 9 minus 3 by 3, and z less than minus 3 by 3. So what is this value? This is z 6 by 3, that is greater than 2, and this is z less than minus 2. Fine. So we know both these values. Right now we have seen probability that z is greater than 2. Let's see this, 2. Probability that z is greater than 2 is same as probability that z is less than 2. So can we directly write this as 2 times of probability that z is greater than 2? And we have also studied that probability, I'll write it in the next page, probability that x is less than minus 1, or I'll say minus a, is same as probability that x is greater than a, and the value is 1 minus probability that x is less than equal to a, or 1 minus phi of a, right? These are all same value. Then in that case, this value of p greater than 2 is same as p less than minus 2. So this is 2 times of p of z greater than 2. So this becomes 2 times of 1 minus probability that z is less than or less than equal to 2, which becomes directly 2 times of 1 minus phi of 2. Of course, we can refer the value for 2 and we'll see 2 is 0.9772. So this is 2 into 1 minus 0.9772, and this will give you 0.0456, right? So some of the things which we can keep it in mind is, although if you don't remember also, you can understand this with the graph. You can understand this with the graph. Anything less than minus a is same as anything greater than a. Anything less greater than minus a is anything less than a. And again, the another relation we saw, that less than minus a is same as greater than a, and it is same as 1 minus x less than a, right?